Okay, these are notes 4.1 homework. Okay, we're given that according to the Book of Odds, the probability that a randomly selected U.S. adult drinks coffee on a given day is 56%. What does this mean? It says if we survey many U.S. adults, okay, so in the long run, we would find 56 out of 100 who consume coffee. Does that mean that if we took 100 people, we would get 56? No. Probably not exactly 56. Probability describes what happens after many repetitions, in this case of 100 of adults. So if we take 100 adults and survey them many times, overall we'll get 56 of them out of the 100 average. Okay, number 2 talks about a college basketball player who makes 75% of her free throws. So in one game she makes 5 in a row. So the next time she gets to the line, the announcer says she's due for a miss. Explain why the announcer is wrong. Okay, well, she's a 75% free throw shooter. Just because she's made her previous shots doesn't mean it's more likely that she's gonna miss her next one. From shot to shot, it doesn't change, right? If she's a 75% shooter, she's a 75% shooter. Doesn't mean if she made or missed before. It's still 75%. Okay, the next problem here, imagine tossing a coin 6 times and recording either heads or tails in each toss. Which is more likely to happen? Heads, tails, heads, tails, tails, heads, or tails, 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 heads, heads, heads. Okay. Both are equally likely to happen in that order because each toss is a 50-50 shot each time. It's 50% heads, 50% tails. So each of these has the same probability of happening. Okay, number 4. A professional tennis player claims to get 90% of her second serves in. In a recent match, the player missed 5 of 20 second serves. So if it was 90% out of 20, I would expect 2, right? But she had 5. Is this a surprising result? Does this give us evidence that she really isn't 90%? Okay, so first let's do a simulation. Describe how you would carry out a simulation to get the 90%. Okay, so this is what I said. You could use slips of paper or like whatever you want. I used numbers, random number generator. I would say the numbers 1 through 9 are a serve in, and the number 10 is a serve that's out. You could take 10 slips of paper and write in on 9 of them and out on a 10th one. That'd be okay to do too, but overall you want to have something that gives you 90% in. Okay, I use a random number generator, select the 20 numbers representing the 20 serves, and record how many were misses and makes. Okay, I'm going to do this many times and record the results. Okay, and if these are those results, so I got random number generator for 20 serves and I had all of them in. That's what this point represents. This point here I had 6 that were out. Okay, etc. So would it be surprised based upon our simulation that we got 5 or more? Okay, 5 or more could happen. Okay, it's not extremely likely to happen, but it could happen. So I said missing 5 could have happened. We would expect 2 out of 20, right? That's why we have most of them here at 2. This would be 90%, 2 out of 20. But having 5 or more isn't that unlikely. Okay, 5 or more is not that unlikely. Okay, number 5 says the figure shows the results of a virtual basketball player shooting 3-point shots. What does this tell you about the short run and the long run? Okay, so looking at the graph here, in the short run, if you just look at the beginning part here, he made the first, like he was 50%, right? And then it kind of went down and he started missing a bunch of shots. But in the long run, after he took many shots, after he took 1,000 shots, he was about at a 30% shooting. Okay, so in the short run, they missed quite a few. Okay, it was a lower percentage made. But in the long run, it shows that after many shots, it was about a 30% 3-point shooter after many shots. Okay, the last one, number 6. Do most teens recycle? A stats class asked a simple random sample of 100 students at their school whether they recycled or not, and they had 55 students say they did. Does that give us convincing evidence that more than half, we want to prove is more than half, okay, of them do? So let's assume that we had at 50%, okay? So we would, if I would take a sample of 100 students, and I was assuming it was at half and half, I would expect 50 of them, right? And that 50% would happen right here. Now, but there's some variation. Not every sample of 100 students would be exactly 50, right? So we would have some variation below and above. Now, if it is 50, is it possible that we could have gotten 55 just by how we surveyed it? People? Yeah. Okay, so part A, I said the graph shows that if the percentage is 50%, then getting an outcome of 55% is not very unlikely. Okay, getting 55% or more is not very unlikely. It's not very significant. Okay, now part B says what if you got a sample of 63%? Okay, so if you got 63 out of 100, which would be this point right here, that's very unusual. It is significant. Okay, which means it's probably not 50%. It's probably more up here. It's probably greater. Okay, so I said if we got a sample of 63 out of 100, 63%, that's not very likely to happen. So it is significant, and the probability is most likely greater than 50%.